Hello viewers, in today's class we are going to discuss the concept of types of discontinuity of a function, right? So here in this lecture we'll discuss the first type of discontinuity of a function, and that is known as discontinuity of the first kind, right? So let us start. Now let us consider a function, say y is equal to f of x, defined in some domain D, right? Okay, so now this function is defined in the domain D, and suppose this function is not continuous at some point, say x is equal to c, belonging to the domain D, right? So we know that the discontinuity of a function implies that either the limit, that is x tends to c, f of x does not exist, right? So if the limit of the function when x approaches to c, it does not exist, or this limit, that is x tends to c, f of x, it exists, but this limit is not equal to the value of the function at the point x is equal to c, right? So here we have two conditions, right? So the first condition is that the limit of the function at x is equal to c does not exist, or the limit exists but this limit is not equal to the value of the function at x is equal to c, right? So when we have these either of these two conditions, then we can say that the function is discontinuous at the given point x is equal to c, right? So whenever a function is discontinuous at some point x is equal to c, then this point is known as a discontinuous point, right? Or we can say that this point is the point of discontinuity. So now there may be different situations when a function is said to be discontinuous, right? So we have many types of discontinuity of a function, right? So in this lecture, we will discuss different types of discontinuity of a function, right? So here we'll discuss the this type of discontinuity of a function, which is known as the discontinuity of the first kind, right? Sometimes the discontinuity of the first kind is also known as the jump discontinuity, right? So here in this lecture we'll discuss the definition of the jump discontinuity or the discontinuity of the first kind, and we'll also see an example where a function is said to have the discontinuity of the first kind or the jump discontinuity. So viewers, let us first take the formal definition of discontinuity of the first kind or the jump discontinuity, right? So a function y is equal to f of x, which is defined in some domain D, is said to have a discontinuity of the first kind or jump discontinuity at x is equal to c if the right hand limit and the left hand limit both exist, but these two limits are not equal, right? So the definition says that a function y is equal to f of x is said to have a jump discontinuity or the discontinuity of the first kind if the right hand limit and the left hand limit both exist, right? But the limits are not equal, right? So whenever this situation occurs, then we can say that this point x is equal to c is said to be jump discontinuity. So now to understand the concept of jump discontinuity, let us consider an example, right? So here we'll take a very nice example and an important example. Let us consider a function f of x that is equal to x plus greatest integer of x, right? And let us take a point, say x is equal to 2, right? So here we have a function which is the sum of the polynomial function, which is simply x, and the greatest integer function, right? And here we are taking x is equal to 2. It means the value of c is equal to 2, right? And here the domain of this function is the set of all real numbers, right? And here we'll see that this function is having a discontinuity of the first kind, or jump discontinuity at x is equal to 2 or c is equal to 2, right? So for this, what we will do, we'll first find the right hand limit of this function, right? So the right hand limit is equal to limit x tends to positive. Here the positive sign shows that we are finding out the right hand limit, and here we have f of x, right? And the left hand limit is having the notation that is limit x tends to 2 minus, and here we have f of x, right? So what we will do, we'll first find the right hand limit and then left hand limit, right? And we'll see that the right hand limit exists and the left hand limit also exists, right? But both these limits are not equal as per this condition, right? So now here to find out the right hand limit, what we will do, here x approaches to 2 from the right of x is equal to 2, right? So here we have x is equal to 2, and while finding out the right hand limit, we are approaching from the right of x is equal to 2, right? So what we will do here, we'll take point, say 2 plus h, right? So 2 plus h is the point which is in the neighborhood of x is equal to 2, right? And when we find out the left hand limit, we'll take a point in the left neighborhood of x is equal to 2, and this point is 2 minus h, right? So now here we'll take x is equal to 2 plus h, and here h is a positive quantity, and h lies between 0 and 1, right? So now the right hand limit is the limit h tends to 0, because when x tends to 2, then obviously h tends to 0, right? So now this limit can be reduced in terms of h. So we have limit h tends to 0, and we have f of x. So for x we can write 2 plus h, right? So now our function is x plus greatest integer of x. So here we have limit h tends to 0, and for x we have 2 plus h, and here we have greatest integer of 2 plus h, right? So now see, here we cannot directly substitute h is equal to 0, right? So what we will do, see, 2 plus h is slightly greater than 2, but it is less than 3, right? So the greatest integer of 2 plus h is equal to 2, right? Because h is a positive quantity and it is infinitesimally very small. So 2 plus h is slightly greater than 2, but it is less than 3. So the greatest integer of 2 plus h is 2. So now here we can write limit h tends to 0, we have 2 plus h, and greatest integer of 2 plus h is simply 2, right? So this is the limit h tends to 0, and 2 plus 2 is 4, so we have 4 plus h, and when we take h is equal to 0, we will have 4 plus 0, that is equal to 4, right? So the right hand limit of this function when x approaches to 2 is equal to 4, right? Now let us find out the left hand limit, right? So here we'll take this point, that is 2 minus h. So we'll take x is equal to 2 minus h. And obviously h is positive quantity and h lies between 0 and 1, and h is infinitesimally very small, right? And when x tends to 2, then h tends to 0, right? So the left hand limit is the limit h tends to 0, and here we have f of 2 minus h, because now x is 2 minus h, right? So now we have limit h tends to 0, f of 2 minus h can be written from this expression. So for x we'll write here 2 minus h, and here we have greatest integer of 2 minus h, right? So now again here we cannot directly substitute h is equal to 0, right? So what we will do, see this quantity 2 minus h, this quantity is slightly greater than 1, and but this is less than 2 because h is positive. So when we subtract h from 2, this quantity is greater than 1 but it is less than 2, right? So the greatest integer of 2 minus h is equal to 1, right? So now we have limit h tends to 0, and this is 2 minus h, and for greatest integer of 2 minus h we can write 1, right? So now the left hand limit is limit h tends to 0, and here we have 2 plus 1 3, so we have 3 minus h. So now h tends to 0, so we have 3 minus 0, that is equal to 3, right? So we see that the left hand limit of this function when x approaches to 2 is equal to 3, right? So viewers, from this discussion, we have seen that this function is having the right hand limit as 4 and left hand limit as 3, right? So although the right hand limit exists and the left hand limit also exists, right? But these two limits are not equal, right? That is, the right hand limit is not equal to the left hand limit, as 4 is not equal to 3, right? So we can claim that this limit, that is limit x tends to 2, because here c is 2, right? So the limit x tends to 2, f of x, it does not exist, right? So we can say that this point c is equal to 2 or x is equal to 2 is a point of jump discontinuity, right?